Today, we will be looking at our solar system and explore how it works. This video will be focusing on our central star known as the Sun. But before we begin exploring the solar system, make sure to subscribe to our channel so you don't miss any of our future videos posted weekly. Alright, so what is the solar system made of? Our solar system is one of many planetary systems orbiting a host star in the Milky Way galaxy. By definition, the solar system is a gravitationally bound system of the Sun and the objects that orbit around it. These objects include planets, dwarf planets, moons, and other smaller masses such as asteroids, comets, and meteoroids. Our planetary system is named the solar system because our star is named Sol, which is derived from the Latin word solis for sun, so anything related to the sun we refer to as solar. The solar system formed about 4.6 billion years ago. It contains a total of 8 celestial bodies orbiting around the sun that are officially recognized as planets. The 4 planets closest to the Sun, Mercury, Venus, Earth, and Mars, are called the terrestrial planets because they have solid rocky surfaces. 2 of the outer planets beyond the orbit of Mars, Jupiter and Saturn, are known as gas giants. The more distant planets, Uranus and Neptune, are called ice giants. Let's take a closer look at each of these celestial bodies, starting with the Sun. The central star of our solar system is the Sun with a mass of about 1.1 times 10 to the 30 kilograms. That is a 1 followed by 30 zeros. It is large enough to fit about 1 million Earths inside its massive body and is the closest star to Earth at an average distance of about 150 million kilometers or 93 million miles. The Sun is mostly composed of ionized gas with 92.1% hydrogen, 7.8% helium, and 0.1% other elements that are held together by gravitational attraction, producing immense pressure and temperature at its center. It is divided into 6 regions: the core, the radiative zone, the convective zone, the photosphere, the chromosphere, and the corona. The temperatures at the core of the Sun can reach up to 15 million degrees Celsius or 27 million degrees Fahrenheit, causing thermonuclear fusion and releasing huge amounts of energy powering the Sun. It takes around 170,000 years for this energy to reach the convective zone from the core due to the energy bouncing around in the radiative zone. Temperatures in the convective zone are about 2 million degrees Celsius or 3.5 million degrees Fahrenheit, where large bubbles of hot plasma rise upwards. The photosphere, or the visible surface of the Sun, is a 500 kilometer thick or 300 mile thick region from where most of the radiation escapes. It takes about 8 minutes for this radiation to reach Earth, which we perceive as sunlight. The temperatures at the photosphere can reach about 5,500 degrees Celsius or 10,000 degrees Fahrenheit, with some areas having strong magnetic fields and being relatively cooler than the rest of the surface. These areas are called sunspots and are mostly darker than the surrounding region. Above the photosphere are the chromosphere and the corona. These regions are usually outshined by the photosphere, making them difficult to see. However, during a total solar eclipse, the chromosphere can be seen as a red rim around the Sun, while the corona forms a beautiful white crown with plasma jetting outward. These massive coronal ejections blasting off the Sun are also known as solar flares, with temperatures reaching quite surprisingly up to 2 million degrees Celsius or 3.5 million degrees Fahrenheit. Our Sun is the most important part of our solar system, providing energy and supporting life on Earth. Without the Sun, life as we know it simply wouldn't be possible. This is it for this video. In the next video, we will talk about the 2 innermost planets of our solar system, Mercury and Venus. If you want to see more content like this, be sure to subscribe to our channel and hit that notification bell. Also give it a thumbs up if you enjoyed this video and comment down below on what you want to see next on Critically Selected. Until then, we'll see you in the next one.